Thank you, everyone, for joining a security talk at 4 p.m. It's a little late in the afternoon for some security topics. However, I'm grateful that you're here. Hope you will enjoy this presentation until the end, that you will learn some useful things that you can take in your daily job. And I'm looking forward to your questions at the end of the presentation. First of all, I'm Anna, currently working as a developer advocate in the Java team at Oracle. I enjoy programming with Java, probably like many of you, since you're in this room today. And of course, I enjoy working with Kubernetes as well. Now, apart from these two passions, I also like security. In my past roles, I like security because I had to, because it's great to build secure software. You have your end users happy when they can safely use their applications. So kind of security, like for many of you, is embedded in the practices that I have when I code. Now, when we talk about Java, I hope that all of us in this room are familiar with the new release cadence, where you get to see many features delivered every 6 months that you can try, that you can give a feedback on. And these features are from multiple areas, many of them on language, others on performance, and some on security. Yet, while these features get like prime time, your daily life can be impacted by those many, many enhancements that are not necessarily formulated in a JEP. And this presentation will show some of those significant changes from 17 to 21. So if I am to ask you, and because this is a big room, I cannot see all of you, but if I am to ask you the question in the slide, can you shout at me, what do you think changed? A change that happened after JDK 17 with the security in JDK? Anything. Just shout it. Records. That's a language feature. Security manager, bingo, that's a very good one. Deprecation for removal, we're going to talk a bit about it. Anything else? Crypto, that's a broad area, we're going to talk about it too. Anything else? What? I didn't understand you. Can you please shout it louder? TLS, yes, TLS enhancements. Yes, all great answers. And many more, because we have 50 minutes for this presentation, so I had to fill it with something. But the reason why we care so much about JDK security as developers is because over time, the algorithms that we're using in our applications weaken and can be exploited more easily. And it happens that a JDK release, take for example JDK 8, can outlast the lifetime when these algorithms are viable. I mean, JDK 8, there's still many applications running on those. So what happens is that the Java platform, the JDK, gets continuously improved so that you can build secure applications. You're building modern applications, but still they have to be secured. You're choosing Java to evolve your applications because you know it's secure. That's one of the main things that comes to your mind. Besides the beautiful language, there are many beautiful languages that you can utilize, but you're also choosing Java because of security. And of course, it's good to say to the business, Java is secure. So, throughout time, I've seen that, well, people can think of Java security as a broad term. So what is Java security? Well, Java security has many components, and since I'm going to reference them in the presentation, I just want you to have a picture in your head when I'm talking about them. So here they are. The Java security components are in the slide. And of course, they start, somebody said records, of course, it starts with the language. But in the case of security itself, that is in the JDK, the higher level abstractions, like you can see here in the slide, they are built on top of lower layer concepts. So this is why it's this like a brick wall diagram. And of course, at the bottom, the Java language is designed to be type safe and easy to use. So it has many features that you probably use in your application. But the foundation of Java security, well, is based on cryptography. So the cryptography component, the Java cryptography architecture, JCA, or JCE, the Java cryptography extension, enables you to encrypt and decrypt data in Java, manage keys, sign and authenticate messages, and much more. Now you have also PKI that contains APIs and implementations for validating and building certification paths or certification chains. Probably many of your applications use certificates. And of course, a way to store those keys and certificates. Next, we go with how the programs can access security services via this lovely acronym, which I'm not going to read from the slide because I'm terrible reading that acronym. But we can talk afterwards what it means. It stands for Generic Security Service Application Program Interface. That's why it's GSS API. And the JDK contains such a GSS API implementation of Kerberos. Now, the transport layer security, which was mentioned earlier, that component is containing APIs for TLS and DTLS. And of course, we're signing jars. So signed jars allow you to apply digital signatures to the jar files in order to ensure that you're sharing those with some data integrity. The data you have in those is shared with data integrity and authenticity. Now the next components, they're together because there are a series of frameworks and APIs that are meant for authentication and authorization. And of course, probably some of you have worked with XML signatures, which are a component, this is a component that contains an API implementation for generating and validating XML signatures. But Java security is more than just APIs built on top on the runtime. It's also tools, because sometimes you need tools in your tool chains to maybe, I don't know, validate your certificates, and of course, if the JDK comes with them, why not use them since they're there? So you get a small set of tools that can help you set security policies. Probably many of you have utilized in this lifetime key tool, at least experimentally. It's for managing key stores, keys, and certificates. Of course, we have Jar Signer, the one that we talked a little bit earlier, for signed jars. That helps, of course, signing those jars. And the last tab are actually the tools for working with Kerberos. But since Kerberos is not so touched, I'll leave them in peace for the moment. So, hope you're feeling happy to explore what happened with JDK security. And we're going to start with the happy parts. Modern cryptographic algorithms. Now, I started this presentation telling you that over time, most or all algorithms weaken, so they can be exploited more easily. Now, if you get stronger algorithms, you can continuously benefit of a stronger foundation for your application. Larger key sizes have been delivered in JDK 20 and 21. So you can benefit of larger key sizes by default. Like in case that when you're relying on the defaults and you're just instantiating something, instantiating a key without specifying the size, although that many examples over the internet can have the size. But if you forget about that, you don't need to worry because the JDK can build that securely at its best for you. So you can have here a table of what changed over time. This is good because this change protects your data and communication by using mathematical techniques that ensure confidentiality, integrity, and authenticity better. Yet, the tides of security threats increase with the advancement of technology. And if you were at the keynote this morning, you probably saw the very nice keynote about AI, how AI can help us. But those were the good parts. AI, and of course, computers that have large, powerful capabilities, well, they can be instrumented for the wrong as well. So if large-scale quantum computers are ever built, this is a hypothesis, all widely used digital signature schemes like DSA, RSA, ECDSA, and so on have the potential to be broken. That's because the power of computation increased. So the IT industry has worked towards the goal of creating post-quantum cryptographic algorithms that are designed to be safe against such powerful capabilities to compute. So as these post-quantum cryptographic algorithms progress and mature, of course, they become standards and are gradually incorporated with the Java security components. So we got the first post-quantum cryptographic algorithms in OpenJDK. And you have here the explanation on the slide so that you would know what it stands for when you read SSS/LMS. So the Leighton-Michaelis signature system is one of these algorithms, and is the stateful hash-based algorithm. It's all based on the hash-based signature scheme, HBS. That's what it's coming from. The hierarchical signature system is the multi-tree variant of the previous one. That's why it's SSS/LMS. And most importantly, it's one of the two quantum-resistant signature algorithms that have been standardized. There is another one. It's called XMSS. It's similar, but it's less popular, so the popular variant was chosen. For the use case of such an algorithm, well, it's used for software or firmware signing, and requires for the key and signature generation to be performed in hardware cryptographic modules, so that because they do not allow secret keying material to be exported even in encrypted form. That's why it makes it quantum resistant. It's hard to export that from the hardware. So if we take a step back, what was done in the JDK, right? If the signature generation happens on hardware, what's happening in the JDK? So when in the JDK side, the signature verification implementation was done. So while the generation happens on hardware, you can verify that signature in the JDK. And of course, you can have here in the slides the explanations on why this algorithm is very great. Another thing that I need to tell you is that this belief that the security of LMS, because it depends on the security of the underlying hash functions, well, it is believed that this security will never be broken by the development of large-scale quantum computers, hence why it's so loved and adopted. Now, how does that look in your code? So how do you verify a signature with this new algorithm? A little bit of code in the slide, just to show you how it looks like. You can use a key factory implementation available from a provider. Now, in this case, if you're running it with OpenJDK distribution, it probably will choose the SAM provider, because that's the first one that it finds it matches it. And that one will read an SSS/LMS public key from its serialized format. So that's reading part. And of course, you need to verify the validity. And probably you've wrote this kind of code sometimes to verify the validity of a signature that uses SSS/LMS. So the thing that changed, of course, is the algorithm being supported. Something that's coming in 22, KeyTool can also operate with this one as well. Right now, it's available at the API level. But in 22, in JDK 22, KeyTool will have that as a feature too. So this one was one of the breakthrough changes of 21. But besides the modern cryptographic algorithms bringing nuance, the JDK restricts the algorithms that are weakened. However, there are multiple ways to limit the usage of vulnerable algorithms. Either the Java limits or disables them to ensure that you are running on a robust environment not only for your own development, but also for your end users. So what was restricted? Some people probably saw that kind of message when they tried to validate a jar that was signed with SHA-1, and that it was having its signature generated before 2019, 1st of January 2019. So you get a warning on that. But what's the story behind it? Why SHA-1 jars were disabled by default in Java 18, as the slide says? Well, it happens that in 2011, the National Institutes of Standards and Technology, NIST, formally deprecated SHA-1 usage and kind of told the people, well, by 2030, you should kind of phase out this usage from digital signatures. That news came 2 years later in 2013. So in consequence, SHA-1 was disabled in TLS server certificates and XML signatures, so it's not just here. Now, in order to make sure that people are not using this any further, JDK security team thought it would be better if your jars, if you try to sign your jars with this algorithm, well, to get the warning that, well, it's not good for you. So there's a way to maintain backwards compatibility, of course, for some of the jars. So if your jar was timestamped prior to 2019-0101 with SHA-1, you kind of get away with it. But if you have like a very strict security team, they can alter a little bit the security rules for you and they can implement it. So I've seen cases when people went even stricter given the threat of SHA-1 usage, so they restricted the security properties even more. We're going to talk about that in a little while. So this was one. Another one delivered, actually more, delivered in 19 and 20. We're disabling weak TLS algorithms. So somebody mentioned TLS. Yes, there were enhancements, but also disabled. Things were disabled with the TLS. So in order to make it harder to use weak 3-DES cipher suits, they have been removed from the TLS cipher suits in JDK 19. Next, 3-DES and ARC4, they're also not very safe. And because they were not very safe, also their homonym TLS ECDH cipher suit also was disabled because it doesn't preserve forward secrecy, and also it was rarely used in practice. Sometimes these algorithms, they're not just insecure, but they're also rarely used in practice, so disabling them is not that difficult. And, well, TLS 1.0 and TLS 1.1, they were disabled from April 2021, but as of JDK 20, DTLS 1.0 is also disabled. Because applications, by the way, should use DTLS 1.2 protocol, which is more secure and supported by the JDK. But in case that you have issues, yes, you can also enable the one that has been disabled. You can re-enable it in the Java security configuration file, but that's something that you do at your own risk. So there's always a way to alter the Java security file, but that's at your own risk when the of course, the guidance says different. Another thing that came in the disabled algorithms area, restriction rules. So how these rules are being put in application, how about these weak algorithms? Because they're not taken out. There needs to be a mechanism for that. So in case of Kerberos, there's a care-by5.conf file where you can set those restriction rules. For security properties of the JDK, of course, is the Java security configuration file, and you can set there. Now, for Kerberos, for those of you that maybe this sounds a little bit foreign, Kerberos is the protocol for authenticated service requests between trusted hosts and across, let's say, a trusted network like internet. But probably you saw Kerberos if you ever configured an application server like in the old times. That's probably you would have seen Kerberos and details about it. In case of those application servers, configuring the care-by5.conf file is crucial. If you're using jars, of course, for jar verification, certificates, TLS, and so on, you can always work with the Java configuration file. So for Kerberos, let's start. How does the removing look like? So in the slide on my left side, I would say, you can find how an excerpt of Kerberos configuration file looks like. And I extracted those two configurations specifically because there's something important with them. So first of all, DES, 3-DES, and RC4 encryption types, well, they were removed from the default list of Kerberos encryption types, but more. They were disabled And you see that there's allow weak crypto properties set to false in the slide, right? Why is that? Well, allow weak crypto properties acting like a global property, and when it's set to true, you're actually allowing all the bad algorithms that you didn't want to have to be selected. So what happens if you want to selectively re-enable some of those removed weak Kerberos encryption types? Because you need it, because your application cannot evolve without those. Your server doesn't start with that in configuration. So in those situations when you are in need, don't go and set allow crypto to true, by the way. You can do that selectively with a second property, with the permitted encryption types. So there you can go and say, hey, I want you to enable selectively these algorithms. Probably they're not secure, or probably some of them are secure, and they haven't been removed, but only do this for only a selected type. Don't do this for everything. They use the global one. So there's a way to escape, but more controlled. And well, it's always to have this message that, well, re-enabling any weak encryption type or any algorithm that's considered disabled is always at your own risk. So be paying attention when you set your configurations. They can work against you. So next, in the JDK security configuration file, this is where you can modify information about your security properties. And we have two types of security properties. So now you're going to see highlighted in the slides the different ones. So the first ones are the disabled ones. This means that this configuration restricts various functionality. Legacy means, the other ones, that you really shouldn't use them because they will be disabled most likely in a future JDK release. So legacy kind of allows you a way to still use them, but be paying attention that sometimes they're going to go in the forever gone category of disabled. Yes, you can alter the list there, but again, at your own risk. So, somebody else said something, JDK 17. Yes, Security Manager. Security Manager was deprecated for removal in JDK 17. But you probably heard a lot about it. It generated a lot of rumor that applications will be so much impacted about this. Even though, to your surprise, you're going to see that, well, it was a feature that was originally designed as a sandbox for running potentially untrusted applets. Who uses applets nowadays? Then it was later enhanced to have a fine-grained permission model. That was never widely used, so pretty much it had a lot of things that were not useful to us. So because of the brittle permission model, difficult programming model, and of course, poor performance, that got to its deprecation for removal in JDK 17. However, Security Manager is still fully supported in JDK 17, but you'll receive warnings at runtime if you try to use it, so probably you've seen that. The other thing is that several APIs in the JDK thought it was a good idea back then to use the Security Manager in the beginning. So because they were tied to Security Manager, there had to be some replacement. There needs something to be done to it once this one is deprecated for removal. And because some applications really wanted to use the Security Manager because they couldn't upgrade very fast in time, but still wanted to take advantage of the Java latest features. It's also good that you can allow the Security Manager temporarily with your application name. But you should know that since JDK 18, is this allowed to use? So there are still ways to use it, but pretty much not good. So let's go back to the API story. There are APIs in the JDK that depend on that, APIs that maybe you need in your day-to-day developer life. So we're going to go to the API enhancements because many of them are related to that. So in the case of the API replacements, the JAWS APIs were the ones that were depending on the Security Manager. So what happened is that the security team has been implementing options to still use the JAWS APIs, but a little different. So for example, the JAWS subject to us and subject gets subject API that depended on the Security Manager. Well, even though they did not require the security manager. That's the fun thing. They depended on that one, but they did not need it. Well, they were replaced in JDK 18 by different APIs in the same class, name subject, right? So let's see how code looks like for such an example. So for example, using the old API, the one depending on security manager, what you need here, you need to perform work as a particular subject, right? But first you require access to, require getting the access control context object first. I don't know why. Well, just use it further and just get the subject. So it was kind of cumbersome. Why was that extra object needed? Well, now you just invoke the current method on the subject, which makes much more sense, right? It's much more clean. You don't need the access control context for that. You're already in the context. Next, related to improvements to APIs, well, there are new APIs for obtaining access to attributes in a key store. So for example, if before JDK 18, this is how you would write a piece of code to get access to the attributes of a key store. So you first needed to get an entry from the key store, then call the get attributes on that entry. Like, okay, so I need to know the entry, then call the attributes on the entry, but I want the key store, right? So why not do that? So that's the improvement in this. It's not just less code, it's just actually not having an extra object when you don't need it. So access an extra object when you actually don't need to use that object further in your code. There are also some improvements to the APIs that customize TLS and DTLS signature schemes. So now there are like setters and getters for getting the signature schemes. And when you need to negotiate a TLS or DTLS connection. And yeah, this is an enhancement for a job regarding the transport layer protocol that was in the past. And also for TLS and DTLS, there's a new API for did I duplicate this? Oh, no. There's a new API for customizing named groups, also for TLS and DTLS. At some point in my slides, you're going to see like a little flying UFO and down there. It's very little, but I'm going to give you access to the slides. Some of the changes that were done in the JDK security were backported as well to 8, 11, and 17. So that's the reason you see the little swords, like the UFO there, also with the backport, so that you know what was affected, and maybe you can use it in prior JDK versions as well. So you get set name groups and get name groups in there. Well, this change was introduced in JDK 20 and allows applications to customize and retrieve the prioritized list of name groups used to negotiate a key exchange mechanism in DTLS or TLS connection. So they're pretty much important at getting access to your prioritized list of name groups when you're making a TLS or DTLS connection. Great improvements on the API. So now we have powerful APIs. But in the beginning, we talked about SSS, LMS, and quantum computers. So let's circle back a little to that. So we get better algorithms that could help us protect our applications against about quantum computer attacks. But how about other techniques, new encryption techniques for securing symmetric keys using public key cryptography? So how about we can enhancing that? So JDK 21 brings a new key encapsulation mechanism API. It's called KEM for short. Now, this is a scheme with public and private keys, which probably you're familiar with. But what's different to it is that the sender uses the public key to create a ciphertext, an encapsulation, containing a randomly chosen symmetric key. And the receiver decrypts the encapsulation with the private key. Now, unlike the traditional cryptography methods, this key encapsulation mechanism is more efficient because it does not require padding when doing the encapsulation. Because, well, it makes the encapsulation by deriving, by using the properties of the public key to derive the related symmetric key that is used there in the shared secret. So, how does that look like? Thought to put it here a little bit in context. So, the sender creates an encapsulation using the public key, right? Then the sender uses CAM to encrypt data using a symmetric algorithm and sends that key encapsulation message to the receiver. The receiver decrypts the key encapsulation message, of course, with the private key. So then the rest, the encryption and the decryption, they are done similarly now that the shared key is known to both of them. So, that said, you can use CAM to first transmit that shared symmetric key and later use it to efficiently encrypt the data using that symmetric algorithm that you chose. Now, the API itself has three parts as discussed earlier with encapsulation, decapsulation, and so on. So the three parts are as follows. Of course, you need to generate the keys. So I need a key pair generation function that is already there actually in the JDK, a key gen to generate the public key and private key. There was nothing changed to that one, but the key pair generator API, it's in the JDK for a while. Now, what was done new for the CAM API was the encapsulation function and, of course, the key decapsulation function that are needed to decapsulate the received shared key. So you can output both the sender and the receiver can trust each other. Moreover, in terms of changes, in the beginning, when we talked about components, there was a component called XML signature. That one suffered a few changes as well. So the API for XML signatures changed a little bit, meaning now that there are two more signature methods URIs that support the Edwards curve digital signature algorithm. That's all ADDSA, which means that, well, now you can sign and verify your XML with these two signature URIs. You can find there the API and the link to it. Now you also have a new system property. I put there system property. I know it's a lot on the slide, but I want you to make the difference between system property and security property so you'll not be confused which to configure where. So there's a new system property that's called secure validation. So it's added there to allow you to easily enable or disable XML signature processing mode. So it has like a simple mode like enable like true or false. But that one, when you set it, it takes into account the secure validation policies properties that you set for your application. So you can strengthen even more the security for your XML signatures if you put this one to true. That's its purpose. Another important aspect that came in 21 is about here function. So here function, it was an XPath function that's defined by W3C recommendation and for XML signatures. And it's being used in XML signatures, of course, has been used so far. Now the thing is that an upstream project that's for XML signatures called Santuario version 3.02 decided to remove this function. However, since there were already applications, Java applications that use XML signatures with here, what the security team thought, it would be better to have a property that has a default value to true and somehow maintain the usage of this function within the existing security keys. The idea is just to have it for the moment, but eventually will be disabled. The support for this one function will be disabled since the upstream project doesn't have it anymore, but gives a way for people to accommodate the changes in their XML signatures until the disable of this one is going to become permanent. Another feature that comes with Java security is the fact that some of its changes are tailored to operating systems. So to operating systems, the operating OS native security features, well, they're typically targeting either Mac, Linux, or Windows. For Windows, historically speaking, before JDK 19, if you wanted to see the keys and certificates in the current user or local machine, you need, of course, access to them. But if you're just using Windows My or Windows Root, you are not getting access to that. So in order to, all the time, you didn't get access to all of those. So in order to personalize this access to the local machine certificates for different users, there has been new types of key store that are called Windows My Local Machine, like an example here, or Windows Root Local Machine key store types. They provide access to keys and certificates stored on the Windows operating systems that are available to all accounts. And of course, there are also ones that are specific to current user, current logged user, because, well, that's to avoid the confusion with the previous Windows My and Windows Root, respectively. All these changes are documented in the JDK Provider's Guide. There's going to be a link at the end of the presentation to that one. Now, macOS. macOS has a story as well. Now, it's starting with JDK 21. You can see only the trusted certificates if you're running this piece of code. So I suggest you to run this piece of code for JDK less than 21, like, I don't know, 17, and compare it to the result on 21. You're going to see to what you really have access to on your local machine if you have a Mac, by the way. So starting with JDK 21, the macOS keychain store implementation exposed certificates that are with proper trust in the user domain, admin domain, or both. So before 21, prints only the user domain certificates. After 21, it prints those that you should have access to. And maybe you have access also to the admin ones, not just the user ones that were before. Okay. What I added here is that the change was backported as well to JDK 11 and 17. So it was an important change that was thought that it would be good also for 11 and 17 to have. Now, updates on JDK kcerts file. Did you use kcerts ever? Yep, so you know what's it. It's kcerts key store is part of the JDK, is intended to contain the root certificates that can be used to establish trust in certificates chain employed by our application, right? By security protocols that are used by our application. So you probably used it in order to establish trust for certain certificates. Now, historically speaking, we used to have the password to change it. We always did the password change it. Now it's no longer required. Of course, it doesn't use the proprietary format anymore. So it uses the PKCS12 format, and if you're using JKS, it will give you a nice warning and tell you, are you sure you want to use this format? And of course, public certificates are no longer encrypted because, well, they're public. Apart from the kcerts improvements, there have been some tools improvements. So the evolution of Java security fostered also a connection to the tools and the monitoring practices, not just enhancements and algorithms and so on. It's also good to keep an eye on what happens there. So the changes with the modernized and disabled algorithms, well, they're very useful also for keytool. So keytool, by the way, besides useful warnings, uses also those default Roger key sizes in gen key pair if the key size option that you give to keytool is not there. So for example, like in this case, I didn't use the minus key size option. And by default, it generated me a key with, of course, the biggest size that was available by default, in my case, 3072. Another improvement as of JDK 21, minus gensec key, and of course, import paths, they warn you if you're trying to use PBI weak algorithms. So they are warning you if you're not doing something right, like in the command here. What this command is doing actually is looking at the key algorithm, which is arc4, and based on that determines that, well, you're trying to use a weak algorithm and I should warn you. Jar signer, we talked a little bit in the beginning, is good for signing jars. SHA-1 were disabled, of course, but As of JDK 19, if you need to specify the class path to an alternate key store implementation, you can now add it with minus provider path option, because sometimes you're not just using the security providers that the JDK comes from, there are other security providers as well, and you want to choose to have one of those for your applications. It can be in the best practices of your company. Some jar signer improvements. Besides all that, there's a command for minus provider path on how it would work with a fictive provider, of course. And last but not least, for monitoring, we have some events that we can look into how the properties of our application have evolved. So there's one initial security property. That's an event for JDK file recorder that we can look on the events when they're initially loaded, when our application starts, what were the security properties that our application started with. Now, this event is very useful when our application changes its security properties in the code, decides to like, okay, I'm going to change this because it's needed and so on. So it's good for keeping an eye on those. If you really want to disable this one because it's enabled by default in the shipped default.gfc and profile.gfc, which are shipped with any JDK, well, you can disable it with these commands if you are interested. Just copy-paste them, it will do the disable, any of them. Another one, recording details about security provider instance requests. So every time that your application is going to access get service method, that is going to be recorded, and information about that is going to be provided. So it serves like an announcement location for what's coming in security. Each change on this roadmap improves security in a different way, in some way. So either, like you saw earlier, restriction or disabling of weak algorithms, or defaults have been increased. Those are documented. SHA-1 jars disabled. Those are documented very well there. Or like tools improvement. That's again documented there. And of course, because these changes can impact you in applications, the Java Crypto Roadmap provides for each of the changes some testing instructions or details how you can revert the change, like I told you in the presentation. Okay, if you really need to enable that weak encryption type in Kerberos, you can do this selectively. So that's available. So it can give you ways to, let's say, perpetuate a bit the change that was done there. So the benefit of the roadmap is that you get advance notice of each change, usually minimum 3-6 months before this happens, and you can test it. So with some exceptions, these changes are backported to all update releases. So that's something very important for you to know as well. Because, well, your applications cannot as well depend, well, your applications need the same level of security across different JDK versions. Maybe you're not using JDK 21 for all of them. You're using JDK 17 or 11. And some of those changes there are backported most of the time. Well, that being said, if you want to know more about the JDK security, there are a series of places where you can find information. So the first place is dev.java. There's a security place where there's a security section that contains several articles on JDK security. More will follow. There's inside.java, where we publish their latest information or research on what happens in the security. So whatever we feel that's relevant and the security teams that's relevant, we put it there on inside.java. And last but not least, on youtube.com/Java, our Java channel, where you can get information on security, but many more language features, which of course we know they're great, we love them, performance tips, and so many, many, many more. So all these places are just a place for security and way more things that can help you in your daily life as Java developers. But I assume that many of you are also experienced Java developers. So if you would like to teach others, or to say to others, explain concepts that are related to Java, it doesn't have to be like advanced concepts of Java. It can be also basic concepts about Java, like enums. You can help us improve dev.java with your contribution, because we're a big community, we're a Java community. We welcome the contributions to dev.java. So we have a repo where you can contribute with articles. If you want to contribute, please make sure to contact me. I'm going to share the link with you. It will be my pleasure to explain to you how that works. You're going to be part of a review process as well, but it would be a great thing for millions of people to read your work. So if you want to know like specific security stuff that are related to this presentation, these are part of the links that I would like to tell you about. So there's a JEP about the deprecation of Security Manager. Probably you've seen that one before. But Sean Mullen is having a very, very insightful blog on JDK security changes. So he captures way more, even those little changes are captured there. So be sure to follow that one as well. My place to go about algorithm names, because I don't know them by heart, so I'm going always to the Java security standard algorithm names. That's a very useful page. And of course, the Java security guide. The roadmap, you can find it there. And of course, there are 2 videos that can help you with security too. So that was it that I was going to tell you about JDK security and what changed on it. It was quite a lot. This is the link to the slides. You can scan it. I'll upload this one to the Jfokus site as well so that you can get it. But if you want it earlier, there's the link to it there. Thank you for listening to me, and now I'm waiting for your questions. Okay. If everything was clear, I'm glad. Or also we can talk afterwards. Oracle has a booth. It's downstairs. So you can find me there tomorrow morning and today, of course, and also at the party. I'll be at the party after the Java user group. Looking forward to seeing as many as possible of you there and have some wonderful conversations on security or other topics. And thank you.